Question number 121. The Owens bridge is particularly useful for measuring of option A, very high value, frequencies of very high value, option B, high value, option C, low value, and option D, very low value. So generally Owens bridge is used for measuring of audio frequency range, and audio frequency range we know that 20 Hz, from 20 Hz to 20 kilohertz. So this is high value. So this is high value, not very high value or low value, because if we consider the very high value, this will be in terms of megahertz, and low value is very low value, that means lower than 20 hertz or 1 hertz, 2 hertz, that is low value, and very low value means less than 1 hertz or 0 hertz, that is a DC signal. So here answer is high value. Question number 122. An Anderson bridge, option A, unknown inductance is measured in terms of known capacitance and resistance. Option B, unknown resistance is measured in terms of capacitance and inductance. Option C, here unknown capacitance is measured in terms of resistance and inductance. Option D, resistance of both inductance and capacitance are measured in terms of resistances. So here option A is the correct answer, that is unknown inductance is measured in terms of known capacitance and resistance. So this is the actual formula. This is the actual formula for inductance, and we use Anderson's bridge to measure inductance, and inductance is measured in terms of capacitance and resistances. So here option A is correct answer. Next question is 123. Question number 123 here. Which AC bridge can be used for the measurement of inductance over a wide range? So here options are given. Option A, Hayes bridge, option B, Anderson's bridge, option C, Maxwell's bridge, and option D, all of the above. So here option A, Hayes bridge, is only used for high Q inductors, and high Q inductors are rarely found. So next is Anderson's bridge, and Anderson's bridge we cannot comment on what type of Q factor inductances are measured generally using Anderson's bridge. Next comes Maxwell's bridge, and there are two types of Maxwell's bridge. One is generally one type of Maxwell's bridge is inductance bridge, and another is inductance capacitance bridge. So inductance capacitance bridge is used to measure the inductances having Q factor of from 1 to 0. So this is general, the inductances are of this range. Generally the inductances are having the Q factor of this range. So this is very wide range. So if we consider both inductance bridge and inductance capacitance bridge, we can say that Maxwell bridge is the bridge which is used for measuring of inductance over a wide range. So here option C is the correct answer. Next question, question number 124. With Kelvin double bridge method for the measurement of resistance, the accuracy can be expected. So here for measurement of low resistances, we use generally Kelvin double bridge method, and if we measure the resistance of value 10 micro ohm to 100 micro ohm, the accuracy is generally 0.5 to 0.2%. Similarly for 100 micro ohm to 1000 micro ohm, this is 0.5% to 0.05%. that means accuracy is decreasing with the increment of the resistance value. So another thing is 1000 micro ohm to 1 ohm, this is 0.05. so here from the options we can say that these values only satisfy this only option D, because in every part of the measurement we can see that accuracy is below 0.5, below or equal to 0.5%. so we can say that 0.5% is the actual answer for this question. Next question is 125. A 230 volt single phase watt hour meter has a constant load of 4 ampere passing through it and 6 hours at unity power factor. The meter disc makes 2208 revolutions during this period. The meter constant in revolutions per second per kilowatt hour each. So here we have to find out meter constant in revolutions per kilowatt hour. So what is the power? So what is the ratings given? 230 volt single phase watt hour meter, constant load of 4 ampere. So here voltage is given, current is given, power factor is given, that is unity, and time is given, that is 6 hour. So what will be the energy consumed in terms of kilowatt hour? So this will be voltage into current into time. So voltage is 230 volt, current is 4 ampere, and generally cos theta is unity, that is power factor unity. So here 1 and into 6 is the time in hours. So here we are getting 5.520 watt hour, and in terms of kilowatt hour this will be 5.52 kilowatt hour, which is equal to 1 unit. So here, and the disk makes 2208 revolutions during this period. So what will be the meter constant? Meter constant will be revolution per unit. That means we are getting this much kilowatt hour, that means 5.52 unit, and revolution what we are getting 2208. So what will be per unit revolution? That will be 2208 by 5.52, which is nearly equal to 400. So here answer is option number C. Next question number 126. Here what is given? While measuring power in a 3-phase circuit by 2 wattmeter method, the reading of the 2 wattmeter will be equal and opposite when option A, power factor is unity, load is balanced, option C, phase angle is between 60 degree and 90 degree, option D, the load is purely inductive. So here what we are getting, one wattmeter will read VL IL by 2 and another will read minus VL IL by 2. And when this occurs when load is purely inductive and there is no resistive part in the load. So at that position no power will be consumed by that inductive load, and one wattmeter will read this one and another wattmeter will read negative this one. So when we add this one, P1 plus P2, we will get 0. That means no power is consumed by that inductive, no active power is consumed by that inductive load. And I have already explained in many videos in my previous videos that how this is coming. So next question is a vector meter used for measurement of option A, power factor, option B, kilowatt and kilo VAR, that is volt ampere reactive, option C, current, option D, all of the above. So vector meter is used for kilowatt and kVAR. That is generally vector meter are tri-vector meters, and they are used for measurement of apparent power, reactive power and real power. So here option B is correct answer. Next question is, actually vector meter measures directly kilowatt, volt ampere and kilovolt ampere reactive. Then from that we can calculate power factor also. So what is actually measuring it? The powers. A bolometer is used in the measurement of option A, VSWR, option B, high voltages, option C, transmission losses, option D, microwave power. So here it measures microwave power, option D here is the correct answer. Which of the following potentiometer has infinite resolution? Option A, deposited field potentiometer, option B, this is Gall-Tinsley potentiometer, option C, Kelvin's double arm potentiometer, and option D, all of the above. So here this one, deposited field potentiometer, is the potentiometer which has generally considered to be having the infinite resolution. Next question is question number 30. In Distel polar type potentiometer, at balance the starter winding of the phase shifter are, sorry I am reading it wrong, in a Distel polar type potentiometer, at balance the starter winding of the phase shifter are adjusted at the phase difference of, this is 90 degree. Next question is, a current transformer has phase error of 3%. The phase angle between the primary and secondary current is. So here this is a very easy thing, because in any transformer primary winding and secondary winding, current has phase shift of 180 degree, not depending upon the, sorry, if we don't consider the load, that means suppose we are connecting purely resistive load, then it will have the phase shift of 180 degree. That means generally voltage is also nearly one, for ideal transformer this will be equal to 180 degree. So if phase error is plus 30 degree, that means actual value will be 177 is a measured value minus, sorry, actual value minus measured value, that means 180 degree minus by this will be equal to 3 degree. That means 3 degree difference in primary and secondary winding currents. In potential transformer, the secondary turns are increased slightly and the primary and secondary windings are wound as closely as possible to compensate for option A, phase angle and ratio error respectively, option B, ratio and phase angle error respectively, option C, any eddy current loss and hysteresis loss respectively, option D, the hysteresis loss and eddy current loss respectively. So what is given in this question? In potential transformer, the secondary turns are increased slightly. So first thing is the secondary turns are increased slightly and the primary and secondary windings are wound as close as possible. Second thing is primary and secondary windings are wound as closely as possible. So this will done for what purpose? These two things are done. First thing is the secondary turns are increased slightly and the second thing is the primary and secondary windings are wound as closely as possible. So for what cause? Option is first thing, that is the secondary turns are increased slightly for ratio error to compensate the ratio error, and the second one, that is we wound the primary and secondary as closely as possible for to compensate the phase angle error. Already I have explained in previous question phase angle error in case of current transformer. Similarly, in phase angle error is also seen in case of voltage transformer, and this can be minimized by making the windings primary and secondary as close as possible. Next question is 133. Which one of the following digital voltmeters is most suitable to eliminate the effect of period noise? Option A, ramp type digital voltmeter, option B, integrating type digital voltmeter, option C, successive approximation type digital voltmeter, option D, servo type digital voltmeter. So here for this purpose, that means is suitable for eliminate the effect of a period noise. For period noise elimination, we generally use the servo type digital voltmeter. So here option D is the correct answer. Next question is a 4 half digit instrument can be maximum reading as it can be written as a 4 half digit instrument can read maximum value as. This can be, actually this language is not perfect. So a 4 half digit, that means there are total 5 digits. 1, 2, 3, 4 and 5. Among these 5 digits, these are full digits, full numbers. That means these numbers can be varied from 0 to 9, and the half represents this one half. This half represents the variation only between 0 and 1, So what will be the maximum value? For this one, the maximum value is only 1, because this can be varied only 0 or 1. What are the maximum values for these? For 9, 9, 9 and 9. 9 is the maximum digit we have. So what will be the maximum reading? Maximum reading is this much. So next question is, a Q meter works on the principle of, this is series resonance circuit. Next question is, a 100 megahertz CRO will have option A 50 megahertz horizontal oscillator, option B 50 hertz 50 megahertz vertical oscillator, option C 50 megahertz sweep, option D none of the above. So here the rating of CRO is 100 megahertz CRO, 100 megahertz CRO. Rating of CRO is 100 megahertz, 100 megahertz. So what it means? It means we can measure 1 by 100 mega, that means 1 by 100 into 10 to the power 6, 10 to the power 6. That means if we convert it to be 10 to the power minus 8, 10 to the power minus 8 second, or 10 nanosecond, 10 nanosecond, we can use the time period of 10 nanosecond in YT mode, in YT mode. That means for a CRO there are two modes, that is one is YY mode, another is YT mode, and this second term represents the x-axis, That means in YY mode we give the two axes x and y, both terminal we will provide two signals, and it will compare x and y and will plot the result, and Lissajous pattern we have seen, and this is the result of YY, this is the result of YY mode. And what is YT mode? Generally we use YT mode to view the waveform or to measure the RMS value, peak value, average value, etc., and the time period, frequency, etc. we can measure using that YT mode. That means x axis is t time, x-axis is time, and y is the signal. So this will represent like this. Suppose this one is a sinusoidal signal, this will represent like this. So in this question given that 100 megahertz CRO will have, so if this is 100 megahertz, so the x-axis should have x-axis, that means x-axis is vertical oscillator, vertical oscillator should have 100 megahertz, because this is the rating of CRO. So option B is not the correct answer. Next is, and what is sweep? Sweep is provided, sweep provides the frequency to that x-axis or the vertical oscillator. So this should also be 100 megahertz, at least 100 megahertz. So option B and C are not correct. And option A 50 megahertz horizontal oscillator, this is also not correct, because in y-axis generally this is not associated with the time domain, because we generally give the amplitude or the signal to that one. We generally not compare the y-axis to frequency or time. In case of digital oscilloscope this is possible, but in case of analog oscilloscope the design is not that robust that we can use that to be a time or frequency measuring axis. So this is also not the correct answer. So here none of the above is the correct answer, that is option D. Next question is question number 137. A Lissajous figure on the CRO scene is shown in the figure. Here the Lissajous pattern is given, and we have to find out which of the statement given below is correct. And what are the statements? First statement is the phase difference between vertical and horizontal signal is 45 degree. Next one, option B, the phase difference between vertical and horizontal signals is 135 degree. Next, option C is the ratio of frequency of horizontal signal to that of vertical signal is half. Option D is the ratio of frequency of vertical signal to that of horizontal signal is 2:3. So what is the answer here? The first thing, Lissajous pattern is given like this. That means we are operating the CRO in YY mode. That means we are providing two signals to both x-axis and y-axis, and y-axis is in the signal mode, not in the time mode. So this will produce a signal like this, and this like signal is produced when the frequency of the two signals which we are providing to x and y are not equal. If the frequency is equal, but the phase difference may or may not arise, then this type of image will not come. The image type will be like this. That means this will be like this, only a straight line, or this, or like this, or like totally circle. And this represents the phase angle. This represents the phase angle. We can find out the phase angle difference between the signals we are providing to x axis and y axis. And how we can find out the phase difference? By this intersection and the sine inverse of small intersection by big. And this is another thing, because here this type of signal or this type of Lissajous pattern are not given. Here what are given? Given like this, So here I have written phase difference is measured in case of two signals having same frequency, but here two signals are having different frequencies, because the Lissajous pattern is not like that. So here option A and option B are not the correct answer, due to this one. Then we have only rest two options, option C and option D. So now we will analyze this one. So what are option C and D are given? Ratio of frequency of horizontal signal to that of vertical signal. That means Fy is the vertical signal and Fx is the horizontal signal. Fy is the vertical signal and Fx is the horizontal signal, and this is equal to frequency of vertical signal by the frequency of horizontal signal is equal to horizontal tangencies by vertical tangencies, that is number of horizontal tangencies by vertical tangencies. So what are the tangencies? Horizontal tangencies and vertical tangencies. So if we draw a line like that, here we will draw line, and here we will draw a line like this. So here this line represents, suppose this one is y axis here represents the vertical axis, and vertical tangency is the Lissajous pattern touching the line how many times, that is called number of tangencies with vertical axis. So here only touching once, because this is like a straight line, only touching once, so this is 1. And how many times it is touching to the horizontal line? Here is 1, here is 2, and here is 3. So we can write it like horizontal tangencies by vertical tangencies is equal to 3 by 1, that is 3:1. And if we see, there is no option like this, so we can say that vertical frequency by horizontal frequency, that is ratio of frequency of vertical signal to that of horizontal signal should be not 2:3, it should be equal to 3:1, not 2:3, because the graph is like this. Suppose I will show you what type of plot will be there. Suppose the plot is given like this, here also another, and here is another, and here is another. So here, like if the plot is like this, and I am not connecting this one, I am only counting here the tangencies. So what will be the tangencies? Here the horizontal tangencies and the vertical tangencies. What are the horizontal tangencies? There is 1, here is 2, and here is 3. And what are the vertical tangencies? Here is 1, here is 2. So for images like that, this will be horizontal by vertical, this will be 3:2. For this like there will be 3:2. And if the Lissajous pattern is like that, suppose like this only, and what are the tangencies? If I draw a line here, what are the tangencies? Here is 1, this will be counted as 1, and here this will be counted as half, so this is 1 plus half, and this will be counted as 1, like this in this question. So this will be 3/2 by 1, that means 3/2 only. So these are the Lissajous pattern problems, and what we are seeing in this question, then there is no correct answer. For this question. The answer will be 3:1 for vertical frequency by horizontal frequency. Next question is, A 0 to 150 voltmeter has a guaranteed accuracy error of 1% of full scale reading. The voltage measured by the instrument is 15 volt. The percentage error will be. So here in this question, what is given? Guaranteed accuracy error is given. Guaranteed accuracy error is always measured on the full scale reading. So what will be the error value? Error value is constant for every measurement. For every what you are measuring, the error will be constant. So what will be the error? Error is 1%. Error is 1% for 150 volt full scale reading. So what will be the error value? Error value is 1 by 100 into 150, that is equal to 1.5 volt. So what voltage we are measuring? That may be 100 volt, that may be 15 volt, that may be 25 volt, 30 volt, any volt. This error will be there. That is why it is called guaranteed accuracy error. So for 15 volt measurement, what will be the relative error? So for 15 volt measurement, the error we know, that is guaranteed error is 1.5 volt. So 1.5 by the true value, that is 15 volt, which is equal to 10%. That is the relative error when we are measuring 15 volt. So here answer is 10%. Answer is 10%. Next question is question number 39. A capacitive transducer consists of two parallel plates of diameter 2 cm each and separated by an air gap of 0.25 millimeter. What is the displacement sensitivity? So in case of capacitive transducer, how generally this works? Suppose this is one plate of parallel plate capacitor, and this one is another plate, and this is the insulator. And capacitance is given by epsilon 0 A by D. So generally in case of capacitive sensor, D is varied. Suppose pressure is applied upon this plate, and this plate is constant. So what will happen? Area is constant here, and D will change. D is the distance between two plates, and this will change. So that capacitance value will vary, and capacitance is connected to a sensitive bridge which will measure the variation in capacitance, and in that term we will measure the mechanical force or any signal or any microwave signal or any acoustic signal using a capacitive sensor. So this is the mechanism of capacitive sensor. So in this question, it is asking that what is the displacement sensitivity. So displacement sensitivity means the plate displacement sensitivity. What is the plate? Plate are the parallel plates which are the two terminals of the capacitor. So here what is the first we will calculate the capacitance, and then we will go for its sensitivity. So for capacitance measurement, what we are given? First thing is diameter is given 2 cm. That means we can find out the area. That is pi d square by 4. Diameter means it is circular. Again this is given that this is air gap. Means epsilon naught we will use, and epsilon r will be 1. So we will use only epsilon naught. And another thing is air gap, and air gap of distance 0.25 mm. That is the value of D. So here capacitance becomes epsilon 0 A by D, and this is and what will be the displacement sensitivity in terms of capacitance by displacement. So this will be, here output is capacitance, so what will be sensitivity? Change in output by change in input. So input is here displacement, that is a D. So C by D, which is equal to epsilon 0 A by D square. So epsilon 0 A by D square. So epsilon 0 value is 8.854 into 10 to the power minus 12 into pi d square by 4 by D square. And what is D? D is given in mm, and here it is given in cm. And answers are options are given in cm. So we will consider centimeter. So we will convert this one to centimeter. 0.25 mm is equal to 0.025 centimeter, and here if we take the square and we will finalize the result, 4.45 into 10 to the power minus 9 Faraday per centimeter, and this is coming to be 44.5 picofarad per centimeter. 44.5 picofarad per centimeter. Here is the answer. Option D is the correct answer. Suppose here given plus 44.4 picofarad, option can also be minus 44.4 picofarad, but this is not correct because because the capacitance is given by epsilon 0 a by d, and for a constant d value, suppose d will be maximum this much and d can move only inward. So when d value decreases, capacitance value will increase, that means positive variation. So this will be plus value, and d, as this one cannot move like this, so this value is always positive. This C variation is always positive, that means will increase the value, capacitance will increase, not decrease. If we allow the upper plate to move outward or move upward, then this will be negative value also possible. So here option D is the correct answer. Next question is, which one of the following thermocouple has highest temperature measuring range? So what are the options given? Options given are copper constanton, iron constanton, option C alumel chromel, option D platinum rhodium platinum. So these are the thermocouple materials. And what is a thermocouple? Thermocouple is the junction of two metals, two different type of metal. When the junction is heated, EMF is produced at the terminals of these metals. This is called Seebeck effect, and Seebeck effect is the principle behind the thermocouples, and these are widely used to measure the temperature for high temperature or also for the low temperature also. So you will see what are the temperature ranges, and we will find out what is the maximum range, what is the highest range, and what are the metal used to that for. So for copper constanton, the range is generally minus 270 degrees Celsius, to plus 370 degrees Celsius, and what is the range? Range is 460 degrees Celsius. What is the range? This is 460 degree Celsius. And next is iron constanton, and what is iron constanton range? This is minus 210 to plus 760 degree Celsius. And what is the range? 970 degree Celsius or Celsius degree. Generally range is range for representing only a temperature, we can say that this is degree Celsius. For the difference of temperature, we generally represent Celsius degree. And next option is alumel chromel. And what are alumel chromel? Here I have already written what are the alumel and chromel. Alumel is the alloy of metals like nickel, aluminum, manganese and silicon. This is the alumel. And what is chromel? Chromel is the alloy of metals like nickel and chromium at their respective percentage. So what are the ranges of alumel chromel? This is minus 200 to 1350 degree Celsius. So what is the range coming to be? Range is coming to be 1550 degree Celsius or Celsius degree. This is highest among these three. And you will find also in books, or this was an previous year ESE engineering services question, and you will find in many books this is the answer. They will give the answer is alumel chromel. And but my analysis, because I have already used platinum rhodium platinum, and that is thermocouple in my lab, and this measures up to 750 degrees Celsius, up to 750 or 700 degrees Celsius. So I will explain how platinum rhodium platinum are used. Generally there are three types of platinum rhodium platinum thermocouples. One is platinum rhodium. This mixture is 10% with platinum pure platinum. This can measure from minus 58 degrees Celsius to 1480 degrees Celsius, and the range is 1538 degrees Celsius, which is lower than alumel chromel, because for alumel chromel the range is 1550 Celsius degree. This is the alumel chromel range. But in case of this one, platinum rhodium of 10% and platinum, this is only 1530. But if we increase the rhodium value, doping or rhodium alloy mixing, suppose this one is platinum rhodium of 30% and again platinum rhodium of 6%. This gives the range from 0 to 1700 Celsius degree. So I have used this one. So I am using, so I can say that here answer should be platinum rhodium platinum, because this has a range up to 700, from 1500 to 700, sorry 700 not 700, 1700 Celsius degree range, 1700 degree Celsius or Celsius degree. What generally why they are not considering this one? Because rhodium is a rare earth element, and platinum also costly, most costly than the gold also. I have also used platinum, and platinum is more costly than that of gold, and rhodium is also an rare earth element. That is why this thermocouple is not a very popular. Although it is popular, it is very costly. So generally for 1400 degree Celsius range we use alumyl chromyl. But if we consider the question is asking for what is the maximum range. Here maximum range will be platinum rhodium platinum for this composition, 30% and 6% in both sides. So next question is in low pressure of the order of 10 to the power minus 6 mm of Hg is to be measured, which of the following instrument would be selected? It should be selected. This is passive sentence. Option A, compound pressure gauge. Option B, thermocouple pressure gauge. Option C, Pirani gauge. Option D, ionization type pressure gauge. So this is Pirani gauge. And I am happy to say that I have also used Pirani gauge to measure the vacuum pressure in my lab also. So next question is, a rosette consists of shielding device for instruments, is a heat dissipating device, controls noise in instruments, consists of 3 strain gauges oriented in different directions. So rosette is a strain gauge, and this measures pressure from 3 directions. Suppose like this 3 different directions. It contains strain gauges 3 different directions. So here next question is question number 3. Which displacement transducer is used for accurate and linear measurement? So this is LVDT, very easy. This is LVDT, linear variable displacement transducer. So this is LVDT. Consider the following statements. Statement number first, the main shortcoming of diaphragm are that they are prone to shock vibrations. The statement second is, diaphragms have the advantages of high accuracy and good dynamic response. Third statement is, selection of materials for diaphragms mainly depends upon temperature range and chemical nature of liquid coming in contact with diaphragm during the pressure measurement. So which of the statements are correct? Actually the 3 statements, first, second and third, all are correct. What are the I want to discuss these statements because these are interesting for pressure measurement, liquid pressure measurement. The main shortcoming of the diaphragm are they are prone to shock vibrations. That means suppose this is a pipe, and here we have suppose the pipe, here is the pipe, and I am putting, here suppose I am here putting a pressure gauge, a pressure gauge having diaphragm. What is diaphragm? There will be 2 stands, and here it will be a diaphragm, and it will sense the pressure. When pressure is like this, so when the liquid flows like this, this will exert a pressure to the walls of that pipe, to the walls of that pipe, and this also exert the pressure on this diaphragm. Also this will exert a force on this diaphragm, and this diaphragm will sense the pressure and it will actuate to the digital meter, and it will show the value. So this is the actual mechanism. So what is the given? Suppose one side of the pipe, this side is closed and no liquid is given from this side, no liquid is given, but due to some reason some air is pressed into the pipe. So what will happen? This air also exert some pressure on this diaphragm, and this will also show some non-zero reading, although there is no water in the pipe, So this is a shortcoming of diaphragm type of sensors, and they are prone to shock vibrations. Next is question, this is also true. Next is diaphragms have the advantage for high accuracy and good dynamic response. So this is correct. These are having good accuracy and high dynamic response. Next is the selection of material for diaphragm mainly depends upon temperature range and chemical nature of liquid coming in contact with diaphragm during the measurement of pressure. So what is this saying? Suppose this diaphragm is consisting of a polymer piezoelectric material. Suppose polymer piezoelectric material like polyvinylidene fluoride or polyvinylidene trifluoroethylene, like that. If this is made up of, and we are allowing suppose hydrofluoric acid, that is hydrofluoric acid or sulfuric acid, H2SO4, and as this is a polymeric diaphragm, this will be melted, because not all the polymers are resistive to acids. Like Teflon is resistive to some of the acids but not all the acids. But suppose I have already explained what may be the polymer or what may be the metal. If we are measuring the pressure of any liquid or anything, so this liquid should support that metal diaphragm. So this option is also correct. These also correct. These are practical things. These are also practical things what we should have considered. Next question number 145. Temperature inside a boiler furnace can be measured by. So by boiler inside the boiler furnace, we generally used optical pyrometer, and in case of optical pyrometers we used pyroelectric materials. What are pyroelectric materials? If we change the temperature of that material, the resistance of that material changes. That is called pyrometric materials. Next is rotameter is used to measure. This is the flow rate. We generally use rotameter to use the flow rate. Next is, as compared to an absorption type of frequency meter, a heterodyne type frequency meter can give higher accuracy. Heterodyne type of frequency meter gives generally higher accuracy. Question number 148. In an analog data acquisition system, DAS, the correct sequence of blocks therein starting from input is. So what is the process or the flow chart? What is the process for data acquisition, analog data acquisition? So what is the process? First, suppose this is the case, and transducer will measure the thing. Transducer will measure what is. Suppose this one is pressure. This one will be the pressure, and this one is the pressure. And I am giving an daily life example. Suppose in a room there is an air conditioner. And the transducer will use the temperature sensing element, and it will measure the temperature. What is the temperature of this room when the air conditioner is already running? And then comes the signal conditioner. What a signal conditioner does? Signal conditioner is the circuit which measures the output of transducer. That means suppose the room temperature is 20 degrees Celsius, but signal conditioner will check the value and compare our input, our human input or the standard value with that actual value, process value. This is called the process value. And what is the standard value or the input value? Suppose we have set by remote, room should have 18 degrees Celsius. So it will compare to this, and then it will record this one, the record, and show us that this is already 20 degrees Celsius and we have set to this is process value and set value is 18 degrees Celsius. So what it will do? It will do again, it will give the feedback, and what it will do? It will again continue running AC so that it will reach again to 18 degrees Celsius. So this is the practical real life example of this process. So what is the actual process? First transducer, then signal conditioner, and then recorder. I have used here the feedback path, but if there is no feedback path also, only you are measuring the things, also this path is followed. Next question is question number 49. Which of the following ADC, analog to digital converter, has highest accuracy? So we have already discussed this question in many exams, and this is the answer is successive approximation type, option A. Next question number 150. A successive approximation type analog to digital converter has a resolution of 20 millivolt. What is the digital output for the analog of 2.17 volt? 2.17 volt. So this is a very lengthy question, so I will explain this one here. I have already done this one, I will only make you understand. So this is a digital electronics question, but in terms of data acquisition, here is asked in measurement or data acquisition system. So what is given? Successive approximation type digital analog to digital converter has a resolution of 20 millivolt. So what are the data given? Two data given here. One is resolution, that is 20 millivolt, and another is analog input, that is 2.17 volt. So if we consider it is a 8-bit system, so here given that it is a 8 bits, no here given, but we can take the option. In the option there are 8 bits, so we can consider it to be 8 bit. So as it is an 8-bit device, so we will consider 1 by 1 bit, and for first bit signal 1,000, first bit, that is this one, and another data are 0, another bits are 0. So what will happen? 20 milli, that is the resolution into 2 to the power 7. 2 to the power 7 is the decimal value of that first bit or first clock. So this results 2.56, which is greater than 2.17. 2.17 is given that analog input. So what will be the digital value? Digital value is 0. Digital value will be 0 because this is greater than. When it is smaller than 2.17, then the bit will be 1. So we have first considered this bit to be 1 and examined, and what we are getting? First bit to be 0, not 1. Then we will constant that bit, that means 8th bit, this bit is constant now, 8 bit is constant now, 0, and we will consider the second bit, that is second bit is considering, we will consider 1 and others are 0, and we will find what is this one. So what will be the output voltage? Output voltage will be 20 millivolt, that is the resolution, into 2 to the power 6, because this total value, this total decimal conversion will be 2 to the power 6, and what we are getting? 1.28, which is smaller than 2.17, which is given to be the analog input. As this is smaller than the analog input, the bit will be 1, so we will retain that one. That means we have considered to be 1 and the answer we are getting 1, so this is retained. So in a next part, these two bits are retained, and next bit we are considering 1 and we will check like that. And what is the process? 20 millivolt, this is the resolution, into the decimal value. What is the decimal value? Here is 1 and here is 1, and what is the decimal value? 2 to the power 6 plus 2 to the power 5. This is 0, 1, 2, 3, 4, 5 and 6. 2 to the power 6 plus 2 to the power 5, and what we are getting again? We are again getting 1.92, which is smaller than 2.17, which is the analog input. So again this will retained, 1 will again retained. this one will again retained. And now in this term, what we are getting, sorry, this will not be 1, this will be 1, these 4 terms, sorry, this is actually like this, these 3 terms are retained, and this will be 1 and this will be 0. Now for this one, we will similarly do resolution into the decimal value 20 milliampere into 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4, and this is coming to be 2 into 2 to the power 2.24, which is greater than 2.17. so as this one is greater than, this will be not 1, this will be 0. so this is the process actually, for a analog to digital converter. If analog input is given and we have to find out the digital output, so this is the case. And how this is operated, this is the total case. And what we are getting, this one is 0, that means here this part we have considered to be 1, but what we are getting 0, so in next part we will take it to be 0, that means 0 1 1 0 0 1 1 0, the first 4 term, 0 1 1 0, then 1 0 0 0 1 0 0 0, so this will be 1 0 0 0, and these are all retained and these are constant values. Now we have to check this one, so we have taken 1, and what we will do, check this one. So 20 milli into 10 to the power 6 plus 10 to the power 5 plus 10 to the power 3, because 10 to the power 4 has already 0, so this will be 10 to the power 3 only. So what we are getting, 2.08, which is smaller than 2.17. As this is smaller than, this will be 1, and in the next part these 5 terms are constant, and we have to check for this term. And what is this one? This one is 20 milli into 2 to the power 6 plus 2 to the power 5 plus 2 to the power 3 plus 2 to the power 2. So this results 2.16, which is smaller than 2.17, which is the analog input given in the question. So as this is smaller than, so this one will be retained, and this we are checking this one, and this will be 1. So now we have these all things are constant, these all things are output constant, and now we have only 2 bits, only 2 bits. So we are checking now this one to be 1, and what will be the answer, we will check. So 20 milli into 2 to the power 6 for this one, 2 to the power 5 for this one, 2 to the power 3 for this one, 2 to the power 2 plus this one, plus 2 for this one, which we are going to check. So this results 2.2, which is greater than 2.17. So this will be 0, this will not be 1, this will be 0. In the next part we will take it to be 0. So this will be 0 1 1 0 0 1 1 0 1 1 0. So these all are now constant. We have only last part remaining, and we will take it to be 1 and check what is the value. So if we take it to be 1, what will be the value? 20 milli into 2 to the power 6 plus 2 to the power 5 plus 2 to the power 3 plus 2 to the power 2 plus 1. Now what is the result? 2.18, which is greater than 2.17. So this will be 0. So this will be 0 as this is greater than. So this value we are getting to be 0. So what are the answers? Answers are the all combinations. Here 0 1 1 0 1 1 0 0. So here answer is this one, that is 0 1 1 0 1 1 0 0 0. This is 0 1 1 0 1 1 0 0. This is the answer. So we need to perform all these things, to find out which is the correct answer, because look at this one, all 4 bits in case of all 3 signals are same. So minimum we have to perform, minimum or 5 stages minimum we have to perform. And in case of if we eliminate this one is eliminated. Now up to 5 stages we are going to eliminate this term, this option. Now also in these two options, these options are same, only the last one is different, So we have to perform all the steps to find out, stages to find out what is the correct answer. So here option A is the correct answer. Next question is, Gauss law is this is closed integral over surface S d dot ds is equal to q, d dot ds is equal to q. This is Gauss law. Directly this is the Gauss law. Next question is question number 152. Charge density of 10 nanocoulomb per meter square is distributed on a plane z is equal to 10 meter. The electric field intensity at the origin is so here this is the electric field intensity due to a infinitely charged sheet. So this is the x, y and z axis, and the sheet is distributed on the plane like this. Here is the plane in z at z is equal to 10 meter, and we have to find out here. So this is below the z, that means the vector is always perpendicular to that surface. Electric field vector will be always perpendicular to that surface, and on which side? On the negative side of z, because we are finding on origin, and this is the direction, and this is the direction, that is minus az direction. So what will be the formula? Formula is rho s, that is the surface density by 2 epsilon. This is the formula for electric field intensity at origin. And what is the rho s? Rho s is given to be 10 nanocoulomb per meter square, and 10 nanocoulomb means 10 into 10 to the power minus 9, and by 2 epsilon naught, and we know that 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. So what will be 1 by 2 epsilon? This will be 2 pi into 9 into 10 to the power 9. So here I have taken 2 pi here to the numerator. So this results 18 pi into 10 to the power 9. So if we put 1 by 2 epsilon value here, 18 pi into 10 to the power 9, what will be this value? Minus 180 pi az cap. So here in the option minus 180 pi az cap. In this question this is written wrong. This is not a2, this is az. Az is the unit vector. Next question number 153. Poisson's equation is del square v is equal to minus rho v by epsilon. Rho v is the volume charge density, and del square is the Laplacian operator. And if it is asking for the Laplace equation indicates del square of any parameter. Suppose I am taking v will be 0. This is the Laplace equation. And what is Poisson's equation? Poisson's equation is non-zero value, that means minus rho v by epsilon. Next question is question number 154. Conductor 1 meter long carries a current of 5 milliampere and is at angle of 30 degree with B is equal to 1.5 Weber per meter square. The magnitude of force is. So here there is a conductor which is moving conductor carrying current. No, it is not moving. Actually this conductor length is given to be 1 meter, and this is carrying current 5 milliampere, and the current direction is 30 degree with respect to that of the magnetic field in which the conductor is placed, and magnetic field is 1.5 Weber per meter square, and we have to find out the force on that current conductor due to that magnetic field. So what is the formula? Formula is F is equal to integration of IDL cross B. So this will be IDL cross B from 0 to 1, because meter long length of that current carrier is 1 meter. So 0 to 1, 5 into 10 to the power minus 3, that is 5 milliampere. 5 milliampere is I into DL. DL is here given, and what is B? B is equal to 1.5 Weber per meter square, and sin theta, because here this one is the cross product. AB sin theta is the cross product. So in cross product, sin theta is given, and theta is given to be 30 degree. So result will be 3.75 into 10 to the power minus 3, and this is 3.75 3.75 milli-Newton. So here answer is 3.75 milli-Newton. Next question is, an infinite number of charges each equal to q are placed along the x-axis at x is equal to 1, x is equal to 2, x is equal to 3 and so on. The potential at the point x is equal to 0 due to the set of charges will be. So this is a very interesting question. So here is the suppose the number line, and here we are putting charges q here, same charges q at 1 2 3 4 5 and so on up to infinite. So what will be the potential due to charge q? This is q by 4 pi epsilon into r. This is the potential due to a charge. Due to so many charges, what will be the potential? This is very simple. This is addition of all the potentials, because the direction is also same and voltage is potential is not a vector quantity also. So q by 4 pi epsilon naught, because q is same for all the values, and what will be the 1 by r values? 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on. This series continues. And if we consider this series, this series may seem to be a convergent series, but this is not convergent. And you cannot find out the answer by q by 4 pi epsilon naught and this series value into this series value, and this series value you cannot find out, because I am explaining this one. In the options there is no such values, and here I would say that there is no correct answer for this one. There is no correct option, because this one we cannot evaluate that series. If you can, please comment below. If you can evaluate this series, please comment below. 1 plus half plus 1 by 3 plus 1 by 4 and so on. If we use software to find out this one, we can use for suppose 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n, and n will be 50,000. So sum will be 11.4. Suppose we are thinking that much also, 11.4. So there is also no answer. And what is this series looks like? This series looks like this. This one suppose 1, this is half, this is 1/3, this is 1/4, this is 1/5, this is 1/6, this is 1/7, and this will looks like this one up to infinite. It seems to be touching and going along with the x-axis. And what are these values? These values is the summation of this one plus 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 this one. So these values are to be added to find out this sum, and if we use software we can find out, but there is no option given here. If you can solve, please comment. Next question is, a small isolated conducting sphere of radius r1 is charged with q plus q coulomb. Surrounding this sphere a concentric with it is a conduction. Actually language given here is not correct. Concentric conducting sphere, direct it should be written. Concentric conducting sphere which is possessed no charge, net charge is given. So the inner radius of the cell is r2 and outer radius is r3. All non-conducting spaces is air. So electric field distribution from r1 and r2 will be from r1 to r2 will be. So here what we are seeing, what is given in this question. So this is a conducting sphere, this one r1 having the radius, this one is a conducting sphere having charge q plus q, and again this is covered by a concentric sphere. This one also conducting one, and this one having no charge, and this is this much thick, because it has inner radius of r2 and outer radius of r3. So question is asking the electric field distribution from r1 to r2 will be. So for this like question, electric field distribution is generally given by 1 by 4 pi epsilon 0 q by 4 pi epsilon naught 1 by r square, 1 by r square, q by 4 pi epsilon naught r square. This is the formula for electric field, and r is the ar cap, and ar cap is the radial vector this way. That means if r increases, e will decrease, in terms of 1 by r square, though there is anything in the medium. And it is in this question, in this question it is only asking for r1 to r2. That means from here to here, from this point to this point. So this medium is air, already given, this medium is already air, so this will follow this path. And what will be the variation will be like this. Suppose this one is E, electric field, and this one is r, radius, and up to r1, and then up to r2, then up to r2, and again r3. So what will be the variation will be like this. As r1 up to r1, that means r1 is the sphere of metal or conducting, so here the field will be zero, and just after the finishing that r1, the field will increase up to the q by 4 pi epsilon naught r square by r square, and as r increases, this will decrease in the terms of 1 by r square, like this, like parabolic form, like this. And again at r2 to r3, this depends upon what type of medium this is. R2 to r3, suppose this is non-conducting or conducting or anything. So in this question, this is not our matter. From r2 to r3, only asking for r1 to r2. This is decreasing in terms of 1 by r square. So next question is, two positive charges q coulombs each are placed at a point 0, 0, 0, 2, 0, 0, while two negative charges q coulombs each in the magnitude are placed at points 0, 2, 0, 2, 0, 0. The electric field intensity at the point 1, 1, 0 each. So here the coordinates are given. One is 0, 0, 0, that means the origin, 2, 2, 0, that means in the xy plane also, and this also 0, 2, 0, 2, 0, 0. That means all the options are given in the xy plane. Z plane is not involved because all the coordinates of z are 0. So we will consider only xy plane. So what are the coordinates and what are the charges given here? So in 0, 0, 0, 0, 0, 0, we are given q charge, and another here given 2, 2, 0, here given q charge, negative charge at 0, 2, 0, 0, 2, 0, negative charge, and 2, 0, 0 is given also negative charge, and asking for the electric field intensity at 1, 1, 0. That means at the middle point, what will be the electric field intensity. And what is the electric field intensity formula? Q by 4 pi epsilon 0 r square, n cap is the direction here. Suppose I am explaining theoretically here, what will be the direction of electric field for this charge? Electric field should be like this, due to the negative charge. This will be like this direction will be like this. At this point, this, due to this negative charge, direction will be like this. Again, due to this negative charge, this direction will be like this, and these two are of same magnitude because q by 4 pi epsilon naught r square, and r here is constant because this is the middle point of this line, So now these two are cancelled out. Again we will consider plus q's. So for plus q, for this one, this will be in this direction, and plus this q, this will be in this direction, and magnitude will be same. Due to this same magnitude and opposite direction, these are also will be cancelled out, and answer will be 0 at 110 point. I have explained that one only. So here the answer will be 0. Next question number 58. Question number 58, 158. Two circular rings carry equal and opposite charges as shown in the figure below. So the dipole moment of the charge distribution is, so in this problem what is given, these are two rings having q charge, here q charge and here minus q charge. So we have to find out what is the dipole moment due to this. So I have not actually experienced this type of question earlier again, because in this question nothing is given about the ring, what type of ring this is, this ring may be a conducting wire or may be an insulator. But for better understanding we are considering that this ring, in this ring the charge is uniformly distributed, throughout the ring, this is uniformly distributed. So if we consider the minimum path, so here is minus q by suppose here this is r1 and this one is r1, and what will be q here? Here the charge will be, suppose minus q, this will be positive, this will be capital Q by 2 pi r1, and here minus q will be same, not same, this is q by 2 pi r2, between this one, because we will if we consider the dipole, this will be the dipole, we cannot say that this may be the dipole, we cannot say, because in the dipole 2 point charges are to be placed at the terminals, not at the middles, because in this point we are getting a point charge here and a point charge here. So this whole line cannot be considered to be one dipole, and we have to consider this much to be a dipole. So what is the dipole moment will be here? Here is the q and here is the q, and if we consider this is the q, that means q by 2 pi r1 into qd. What is d here? D is this much, that means small d minus r1 plus r2, but in this question options there is nothing options like this. So what I have arranged and decided to tell you that in this question we have to consider that these charges are here, only, and we have to directly consider the d is the distance between two charges, and we have to consider the charges to be pointed at the center of those rings, and to be considered to be point charges. So that what will be the answer will be only the qd, very simply the qd. Q is the charge and d is the distance between the two centers. So here I am selecting the option qd only. Next is, two concentric spherical cells carry equal and opposite uniformly distributed charges over their surfaces as shown below. The electric field on the surface of the inner cell will be, so here we have to find out inner cell, what is this one is asking, two concentric spherical cells carry equal and opposite uniformly distributed charges over surfaces. So inner cell is not this one, inner cell is this one, and here the radius is r, and we are getting q. So what will be the charge, what will be the electric field? Electric field will be q by 4 pi epsilon naught r square, simply this one. If this have asked for the electric field at this point, this will be at this point, and no outer cell is given, so this will be q by 4 pi epsilon naught 2r square, and this will be q by 4 pi epsilon 16 pi epsilon r square. This is option D. So but here given that inner surface means that one at r, so answer will be this one, q by 4 pi epsilon r square. Next question number 160. In this question what is given? Relation between electric intensity E voltage applied V and the distance D between the plates of a parallel plate condenser is, parallel plate capacitor or condenser is, E is equal to V by D. E is equal to V by D. You can also use the dimension or the unit convention to find out the result also. Next question. Here in this question, assertion and region are given like engineering services questions, and here assertion is given: when there is no charge in the interior of a conductor, the electric field intensity is infinite. And region is given: as per Gauss law, the total outward electric flux through any closed surface constituted inside the conductor must vanish. So in this two statements, first, that is assertion, is wrong, because when there is no charge in the interior of a conductor, the electric field intensity is zero, not infinite. So here A is false, R is true. A is false, R is true. Next question is 162. 162 given: a charge is uniformly distributed throughout the sphere of radius A, taking the potential at infinite at 0. The potential at R is equal to B smaller than A is. This is how this is. Suppose this one is the uniformly distributed throughout the sphere of radius A, and if at infinite the potential is 0, potential at infinite and 0, but we have to find out at B which is smaller than A, so E is equal to Q by 4 pi epsilon naught R square A R cap. R is the radial vector, unit vector, and this is 0 for A is greater than R, but R is smaller than A. That means within the sphere the field is 0. Outer the sphere it is increasing, and at infinite it is again 0. This is the thing. So here what we are observing, potential at point R is equal to B, where B is smaller than A is. So what will be this one? That means inside the sphere. So this is V is equal to, we know that, minus E dot R integration. So minus infinite to B, from infinite to B. This is the definition of potential difference. So from infinite to B, minus E dot dr, and this will be again divided into two part of integration, from infinite to A, and then again from A to B, E dot dr, and this will be for this one from A to B. As this is 0, we have already discussed, inside the sphere field will be 0, but outside the sphere this will be minus from infinite to A Q by 4 pi epsilon naught R square. So here option D is correct answer, that is minus infinite to A Q by 4 pi epsilon naught R square dr. Next is 163 question number. An infinite charged conducting plate is placed between and parallel to two infinite conducting grounded plates as shown. The ratio of charge densities sigma 1 and sigma 2 on the two sides of the plate will be. So as both this is grounded and this is also grounded, so what will happen here? The potential difference will be same. The potential difference will be same, sigma 1 and sigma 2. That means this one sigma 1 and this one sigma 2 will be, sigma 1 by sigma 2 will be depending upon directly d1 by d2. That means this potential, this charge density will depend upon d1, and this one will depend on d1 by d2. So here option D is the correct answer. Next question is, C0 is the capacitance of a parallel plate capacitor with air as a dielectric, as in the figure A. if half of the entire gap as shown in figure B is filled with a dielectric of permittivity epsilon r, the expression for the modified capacitor is. So here this one is the first case and this one is the second case. For first case, what is the capacitance? C naught is equal to epsilon naught A by D, and here when half of the capacitor is filled with another dielectric having permittivity epsilon r, so this will be a system of two parallel capacitors, and the capacitance will be C is equal to C1 plus C2. So now what are the capacitances? Epsilon naught A by 2 by D plus, because area is now half, this one is half area and this one is another half area, so area is now half, by D plus epsilon naught epsilon r A by 2, and if we take common epsilon naught A by 2D, what will happen? This will be 1 plus epsilon r, and this will be C0 by 2 into 1 plus epsilon r, C0 by 2 into 1 plus epsilon r. So here answer is this one, A, C naught by 2 1 plus epsilon r. Next question is question number 65. Question number 165. Sorry, 165 maybe this side. Yes, here. A hollow metallic sphere of radius r is kept at a potential of 1 volt. The total electric flux coming out of the concentric sphere surface of radius r, capital R, greater than small r is, this is directly, the formula is 4 pi epsilon small r, that is the radius of that small sphere. Next question, question number 166. A parallel plate capacitor filled with two dielectrics is shown in the figure below. If the electric field in the region A is 4 kV per centimeter, the electric field in the region B in kV per centimeter will be. So in this field, in this region, the field is 4 kV per centimeter. Then what will be the field in this region? So as we are seeing, this is a same plate, this is the same plate and this is the same plate. So potential difference will be always same. Potential difference in between the two plates, suppose this one is X and this one is Y, is always same, as these are connected, or we can say that these are parallelly connected. So as the potential difference is same and the distance is also same, regardless of the dielectric material within that plates, the field will be same. That means here also the distance is 2 centimeter. So we can find out that the potential V, we can write that V is equal to 4 kV per cm into 2 cm. 2 cm is the distance here, so 4 is the field, so this will be 8 kV, and same 8 kV will appear here at B region, and here distance is also same, so here also field will be 4 kV per cm again. So here answer will be 4 kV per cm, option C. Next question is question number 167. In a charged 1.0 coulomb is, if a charge 1.0 coulomb is moving with a velocity 2.0 ax in a magnetic field of B is equal to 1 ay, the force on the charge is. So here what is given? Force can be given as, for a moving charge in a magnetic field, we can find out the force like this: F is equal to Q V into V cross B, and here as this is a cross product, Q V B sin theta, and sin theta is given to be 90 degree, because the velocity in x direction ax and b is in y direction, in y axis, and the angle between x and y direction is 90 degree. So this will be 1 into 2 into 1, because 2 is given to be the velocity, this will be, and sin 90 is 1, this is 2a z cap. And how this is z cap? V cross B, V is given to be y, V is this one and B is this one, this one is V and this one is B, and cross product, if we cross product this much, V cross B, this will be like this, like Z, in Z direction, which is perpendicular to both V and B. Next question is 168. If mu is equal to 1 microhenry per meter for a medium H is equal to 2 ampere per meter, the energy stored in the field is. So energy stored is given by half mu h square. Half mu h square, half into mu is given 1 and h square, h is given to be 2. So what will be the answer? Half into 1 into 1 into mu is given to be 1 microhenry. Mu is given to be 1 microhenry. So this will be half into 1 microhenry into 2 to the power 2, that is 2 square, and what we are getting 2 microjoule per meter cube. So here answer C is the correct answer. Next question 169. And in this question what is given? The magnetic flux density B and the vector magnetic potential A are related by B is equal to del cross A, that means curl of magnetic potential gives the flux density. Magnetic flux density is the curl of magnetic potential. Next is magnetic field due to an infinite linear conductor carrying current I at a point P at a distance R each. So this is what is given, that 1 by 2 pi r. 1 by 2 pi r is the magnetic field formula. This is the magnetic field due to an infinite linear conductor carrying current I. This is not 1, this is I by 2 pi r. That means current by 2 pi r. And what will be the direction? Direction is given by, suppose this one is the infinite conductor and this one is the P, where we want to find out the magnetic field. Yes, magnetic field. Then the direction of a field will be AL cross this one, AL cross AP. So for this one the direction will be inward. And in this question no direction is given, only values are given, and the worst part is pi is given to be tau. Written is pi, this is pi actually, not tau. I by 2 pi r, not 2 tau r. 2 pi r, because pi is a constant value. So here option B is correct only when this is not tau, this is pi. Next question is question number 171. The energy stored in the magnetic field of a solenoid 30 cm long and 3 cm diameter wound with 1000 tons of wire carrying a current of 10 ampere each. So here a solenoid is given, and if we want to find out the energy stored in it, we have to find out the L, that is self inductance, and then we will apply energy is equal to half L I square. So here what will be the L? L is the N square mu A by L, and what is A is the area and L is the length. And if we put the values, N is the number of tons, 1000 square into mu is 4 pi into 10 to the power minus 7 into A is the area, and area is pi d square by 4, and d is given to be 3 centimeter, and we have to convert it 3 centimeter to meter, that will be 0.03 square by 4. Here is the area, and if we consider this one and find out the final value, this will be 2.96 into 10 to the power minus 3 Henry. This is the L value. And what will be the energy? Energy is half L I square, that is half into 2.96 into 10 to the power minus 3 into 10 square, which is equal to this much, 0.15 joule. Current is given here, 10 ampere, so 0.15 joule. So here option B is the correct answer. Next question is question number 172. The inductance of a long solenoid length 1000 mm wound uniformly with 3000 tons on a cylindrical paper tube of 60 mm diameter. So here L is equal to mu n square A by L, the previous formula, and if we put the values and convert those mm to meter, what we are getting? We are getting direct 32 millihenry directly. Next question Question number 173. A straight conductor of length I moving with a velocity v in the presence of a magnetic field of flux density v directed at an angle theta with the direction of v experiences a force. Which of the following statements is or are true for the magnitude of the force? So here first statement is given. It is dependent on theta, it is proportional to I square, it is proportional to b, it is independent of v. So here which is true given? Select the correct answer from the given. Select the correct answer. Which of the following statement is a magnitude of the force? So magnitude of force will depend upon theta, because the magnitude depends upon b cross v. So this is depending upon b. So this option will be wrong because this is independent given. It is proportional to v, correct. It is proportional to I square. Here also I is a scalar quantity, not I square. So this is also wrong, and it is independent of theta, as this is a cross product v sin theta. So depending upon theta. So this is also wrong. So here which is the correct statement? Only third statement, that is the correct statement only here. Next, which law is synonymous to the occurrence of diamagnetism? This is Lenz's law. Because what Lenz's law describes, there will be the Lenz's law gives the polarity to the EMF generated or EMF induced according to the Faraday's law. And what is this giving? Lenz's law describes the cause. Cause is the effect of that. Cause is the opposite of that effect of EMF induced, which is given by Faraday's law of electromagnetic induction. And due to that Lenz's law, we put negative sign, that is minus d phi by n d phi by dt. Minus is given due to that Lenz's law. And in case of diamagnetic materials, what happens? The spin of electrons cancels each other to be neutral, so that it is called a diamagnetic metal. And why when the diamagnetic material is placed in a magnetic field, the spin of the electrons of that material causes and opposes the cause. Cause is the electric field in which we are placing that diamagnetic material. Cause is the electric field, and the result is the spins of electrons will cancel each other to form zero magnetization, and that is why they are called diamagnetic materials. So this is the effect of Lenz's law. Next is, but in case of magnetic metal or ferromagnetic metal like nickel or iron or cobalt, what happens? Or paramagnetic metal also, some of the spins remain in their position, not cancel out each other, and be magnetized, and remnant polarization also present in case of ferromagnetic materials. The next question is, the magnetic reluctance of a magnetic circuit decreases with option A, decrease in cross sectional area, increase in cross sectional area, increase in length of magnetic path, decrease in relative permittivity of magnetic material of the circuit. So here reluctance S is given by L by mu naught mu r A. So here cross sectional area is A, and if it increases, this decreases. So here option B is the correct answer. It is given that increases length. If L increases, this will increase, not decrease here, but here it is given that decreases with. So option B here is the correct answer. Question number 176. Lower the self inductance of a coil. Option A, more will be the Weber turns. Option B, more will be the EMF induced. Option C, lesser the flux produced by it. Option D, smaller the delay in establishing steady current in it. So it is given by V is equal to L di by dt. So for steady current, self inductance should be low. Self inductance should be low. So option D here is the correct answer. Next question is given that a small saw cut is made in a permanent magnet of toroidal shape. Which of the following are true for H0 if H0 is the magnetic field and Hi is the inside the magnet? So here language is given not wrong. Actually H0 is the outside magnetic field and Hi is the inside magnetic field. So we have to find out the relation between H0 and Hi. So what is the toroidal shape? So in case of electromagnet, this is the toroidal shape. Toroidal shape means suppose this one is connected, that means if we wind a wire like solenoid on a ring, on a metallic ring, this will be a toroidal shape. And in case of permanent magnet, toroidal shape is just like a ring of a permanent magnet. And what is given that a saw cut is made in the permanent magnet of toroidal shape. Toroidal shape means this one. I have made a saw cut here. So what will happen? Suppose here this is Hi and here this is H out. What will happen between Hi and H out? So here in case of electromagnet, what we find, Bi is equal to mu naught Ni by 2 pi r. That means and this is B naught is 0 for B. Here B is 0, B is here 0, and here B in is this formula. And the B is highest here and decreases gradually because this is depending upon 1 by r. So in case of permanent magnet also this behavior is maintained, and B is directly proportional to H. So H also will behave like this. So what we can say that here H output is 0. So H output is smaller than H in. This is always true. Option 1 is always true. This is wrong. Next is H0 in the direction same as Hi. H0 is not in the same direction because if we explain this one from center, this is decreasing. This is B is decreasing and hence H is also decreasing. That means in this from this, the H is in this direction, I can consider it to be Hi, and in this direction I can consider it to be B output. That is why this B output is opposing B input, B out, B in. Both are opposing each other, so that at this point this is 0, and at this point B out is 0, and Bi is maximum. So we can say that H0 and Hi are in opposite direction. So here what are the options given? 1 and 4th are true. 1 and 4th are true. So here option B is the correct answer. Option 1 and 4th are true. Next question is, and again in case of this toroidal shape, there is no north and south for this one. No north and south. The field is like this. And if I cut like this, then one part will be north and another part will be south. One will be north and one part will be south. And the field will be like this here. Next question is question number 178. If two windings having self inductances L1 and L2 and the mutual inductance M are connected in series with opposite polarity, then the total inductance of the series combination, this is directly the formula L1 plus L2 minus 2M, because they are opposing. Option A is the correct answer. Next is 139 question. Question number 139, and this in this question given, when two coils having self inductances of L1 and L2 are coupled through a mutual inductance M, the coefficient of coupling is K is equal to M by root over of L1 L2. This is definition and directly the answer. Last question of this paper 1 is question number 180. Two coils having equal resistances but different inductances are connected in series. The time constant of the series combination is the how we can say that, suppose two coils having equal, suppose this one is one coil and this one is another coil, and two coils having equal resistances. Here this one is R1, equal resistance but different inductances. Here R are connected in series, and here L1 and here L2. These are given things, and the time constant of the series combination is, series combination, what will be the time constant for this one? Now for this one, what will be the time constant? For this part, the time constant will be L1 by R, and for this part this will be by L2 by R. These are the time constants. I can say that this one is tau 1 and this one is tau 2. So what will be the time constant of the combination, series combination? See, if we consider the series combination, total inductance will be L1 plus L2, and what will be the resistance? Resistance will be 2R, because R and R are constant for both, resistances are constant for both the inductors. So what will be the resultant time constant? This will be tau is equal to L1 plus L2 by 2R, which is equal to tau 1 plus tau 2 by 2, which is equal to tau 1 plus tau 2 by 2. That means average of time constants of individual, average of time constants of individual coils. So here option B is correct answer. So I have done a lot of works to solve all these questions, and I am also taking and working on the second paper. So please comment on the questions which you want to describe your answer, or I have made any mistakes in those questions or solutions. Please mention those in the comment section, and thank you for watching up to here.